Okay, so today we are going to start our chapter of physics, which is work, power, and energy, right? So we are going to start today our chapter work, power, and energy. As you can see the topic here, right? So initially we will be discussing about work in very detail, then we will be going towards power, and after completing power, definitely we'll go towards energy, right? So what is work? Work, basically it states that when a force acts on an object and the object moves, we call it force has done work on the object, right? What did I say? Let me write the definition here. What did I see here? I said it states that when a force is applied to a body, or when a force acts on an object or a body object and the object moves. Where does it move? It moves in the direction of the force. Moves in the direction of force. We say that the force has done work on an object. Now, what does this mean? Let's understand this. I have written here. It states that when a force acts on a body, and it covers displacement along the direction of a force, we say that force has done work. Right now, basically, if I have wait, if I have one object, right? I have, for suppose, I have this car. Let me make here the car. This is car basically. This is car I have. And here I am applying force to this body, right? I am applying what? Force, right? Inclined force. So this is inclined force. Now, of course, this is not possible if I'm gonna apply the force on an object or on a car. It will come towards me. However, it will cover the displace along the x-axis, right? So it will gonna cover the displacement along this axis, right? So we have applied force inclinedly and it is covering displacement along the direction of x-axis. Displacement right? Displacement along x-axis. Now, as I have written here, we have to apply a force and a body has to cover the displacement in the direction of force. Now, either we can take the component of displacement in the direction of force, or I can take the component of force in the direction of displacement as well, right? So here what I am going to do, I am going to take the component of force in the direction of displacement. It will gonna make, basically it can make two components. One would be here, one component would be here, right? And this component would be known as f cos theta, since it is in the direction of the x-axis, right? And one component, it will be here, right? And this would be f sine theta, since this is in the direction of y-axis, right? So I need to take that component which is responsible for this displacement, and I know that which component of force is responsible for covering the displacement. Of course, the component is f cos theta. So I need to take this f cos theta, right? Because this is responsible to displace this particular object. I have taken this component and now I'm gonna write here, wait, f cos theta. Since this particular component is responsible for making or for covering the displacement, f cos, we have theta, I guess I don't have theta here. It's okay if I don't have theta here. I'm gonna write with my pen, right? So I'm leaving the place for theta. Then f cos theta, and we need to multiply this with displacement, right? Because since the body is covering displacement, so we are replacing displacement with d, right? D, which will be equal to work, right? Here let me make theta, cos theta. So f cos theta into d is equal to work. Now we know that force is the vector quantity as well and displacement is the vector quantity too. So let me make the arrows on the up so that we can identify these both are vectors, right? Now I know that these both are vectors. When these vectors, when I'm gonna replace, or I can say I'm gonna remove this cos theta, what will be between them? There will be dot, right? F, or I can write like this as well, fd. I am writing physical quantities together and then cos theta on the other hand, right, is equal to work again. Now I want to remove this particular cos theta, right? For removing this particular cos theta, I have to put the dot, right? Dot between force and displacement. So force dot displacement is equal to work, because I know that when I'll be removing this particular dot, there is the dot product of forces displacement. When I'll remove this dot, there would be cos theta, right? Then ultimately we'll be having formula of ft cos theta. So let me write here this down as well. Work is basically, so here we have got a second definition as well. Which second definition I've got here? Let me write that. Work is the dot product. I'm going to explain you what is this dot product, right? Dot product of force and displacement, right? Force and displacement. Work is nothing but it is the dot product of force and displacement, right? Now let me tell you what is this dot product mean, right? When I have vector quantities, I know what are vector quantity. Vector quantity are those quantities which have magnitude and have particular direction, and the quantities which follow the vector law of addition are known as vector quantities. So when I am multiplying two vectors together, right, let me write here. Okay, what I'm doing here, okay. So when I am multiplying two vectors together, for example, I have one vector and I have another vector as well, right? I am multiplying these both together, or I can put here dot, right? Because I am taking the dot product of two vectors. So it will always gonna give me the scalar quantity. It will always gonna give me the scalar quantity. Means the dot between two vectors will always gonna give me a scalar quantity as in the product, right? And when I am having cross product of the two vectors, cross product of two vectors will always I get will be vector, right? So vector dot vector will gonna give me a scalar quantity. However, vector cross vector will gonna give me a vector quantity. If I am gonna remove this dot, right, as I know this is the dot. If I'm going to remove this dot, what I'm going to get between these two vectors will be, wait, I'll be getting vector, I'll be getting another vector as well, right? Vector, vector. By removing this dot, I get cos theta. Cos theta. Vector, vector, cos theta, right? When I remove this dot. But when I remove this cross, since this is a cross product, right? This is the cross product. When I remove this cross, what do I get is, wait, let me write here. I have one vector. When I did cross multiplication of that vector with an other vector, when I'll remove that cross, I'll get cos sine theta. Sorry, sine theta, not cos sine theta. Sine theta, right? Sine theta. And in the result of this, I'm always gonna get, when I have dot product, right? In the result of the dot product between two vectors, I'm always gonna get the scalar quantity. The scalar quantity is that quantity which has magnitude but not direction, right? So let me write that too. Wait, let me highlight this too. A physical quantity which or that has magnitude. Now magnitude includes both numerical value and the direction, numerical value and the unit, but not have a particular direction, right? Particular direction is called scalar quantity, right? So here I have written the definition of this as well. What is scalar quantity? A physical quantity that has magnitude but not have particular direction, right? Now if I have cross between the two vectors, then I am going to get sine theta, and in the result I am always going to get will be what? It will be vector. And what is vector quantity? This is a physical quantity, so I'm just gonna make this, which has particular magnitude, means it has numerical value as well as it has unit as well. These both things are included in the magnitude. Let me write here the direction because it contains direction. Magnitude and has particular direction as well, and follows the vector law of addition or vector laws, right? They follow vector laws. So I hope this is clear to you, what we have dot product and what we have cross product. Now I'm going to tell you some characteristics of work. For example, what's the unit of the work in the SS system and in the CGS system. We are going to talk about the FPS system as well, and then I'm going to tell you the which quantity is this, like is this a scalar quantity or is this a vector quantity. As I've already explained you what we're going to get when we have dot between two vectors, but I'm going to explain you this again, right? So work is actually wait, let me highlight this. Work is a scalar quantity. Why it is a scalar quantity? Let me write the reasons as well. Work is a scalar quantity because it is the dot product of force and displacement. Force and displacement. And when we remove this dot, we get component of cos theta, right? Cos theta, I'm gonna write like this, theta. And we know that when there is a dot between the two vectors, it will always gonna give us the answer as the vector quantity, not a vector quantity, however scalar quantity, right? And when there is a cross between the two vectors, it will gonna give us the product of vector, right? So work is a scalar quantity. Work is a scalar quantity. Here we have concluded this. Right, because it is the force, a dot product of force and displacement. When we remove this dot, we get FD cos theta. FD cos theta, because there was a dot between these two vectors, it will gonna give us the scalar quantity, right? It will gonna give us scalar quantity. Now let me tell you the unit of this, right? So the unit in the SI system is Newton meter, which is equivalent to joule, right? So the unit of work, the SI unit of work is not joule, however it is Newton meter, but it is equivalent to joule. In the MKS system, it is Newton meter. Let me write that here. In the MKS system, the unit of work is I have to move there. The unit of work is Newton meter. Newton meter, and that is equivalent to or equal to joule in SI system. Or in SI, right? In SI, the unit of work is joule, right? And in the FPS system, wait, let me write that. In the FPS system, F represents the foot, which is the unit of length, right? Unit of length. Pound, P represents the pound, which is the unit of force, right? Is the unit of force. And S represents second. S represents second, which is the unit of time. Right? So we know that the formula of work is what? It is force displacement, right? Force dot displacement. So work, here we have the unit of force is pound, right? So here pound is represented by LB dot displacement, means the length unit is foot, and foot is represented by FT. So the unit of work in the FPS system is LBFT, which means force into displacement, or which you can say is the foot pound, right? This is pound, this is foot, which means foot pound is the unit of work in the FPS system. So this was all for today. In the next video, we're gonna go with the positive work, negative work, and zero work, when they do become positive work, when they do become negative, and when they do become zero work.